This is your Chapter 9 test review for transformations. For numbers 1 through 5, decide whether each transformation is a translation, reflection, rotation, or dilation. If it is a dilation, state whether it is a reduction or an enlargement. Okay, I'll give you a second to look at number 1. Decide how that figure is being transformed. As you can see, it is being slid to the right and nothing else is happening, so transformation that slides the original figure is known as a translation. So number 1 is translation. Number 2, we've got the circle here and the new circle is here. As we can see, that one is changing the size of it. The only one here that changes the size is a dilation. It says if it's a dilation, state whether it's a reduction or an enlargement. As we can see, this is getting smaller, so this is going to be a reduction. Number 3. That looks like it's just the same size, but it's just being moved over there with no turning or anything else. So this one we're going to say is another translation. Number 4. Everything looks the same except the size, so we know this is a dilation, and since it's getting bigger or larger, we'll call it an enlargement. And number 5, picture down here, it's being turned to the right, so that will be a rotation. And the angle of rotation, since it's being turned a quarter of the way around the circle, is 90 degrees. Number 6, determine the number of lines of symmetry for each figure. Okay, let's look for this one over here. Line of symmetry. We also call it fold line. Where can we fold it over onto itself? And we can draw the line straight down the middle. That's 1. We can go one straight down the middle this way. That's 2. And let's see, can we go around the diagonal? Looks like it. We can put one on the diagonal right here. And we can put one on the diagonal here. So the answer for number 6 is 4. Number 7. The only way that we can fold this is right down the middle, right there. The answer to this is 1. Number 8. Determine if the figure has rotational symmetry, point symmetry, or neither. Remember, rotational symmetry means you can rotate the figure less than 360 degrees and it will map onto itself. Point symmetry means exactly 180 degrees. Let's look at number 8. I see that if I turn this, since this is a regular pentagon, if I turn this to here, it will look the same. If I turn it to here, it'll look the same. Here it'll look the same. Here it'll look the same. So it definitely has rotational symmetry. So to find the angle of rotation, or AOR, you're going to take the total of the exterior angles, which is 360, divided by the number of sides, and that's 5. So we're going to divide that out. 360 divided by 5 is 72. So our angle of rotation is 72. Point symmetry would be 180. This would have to map halfway around the circle down here, and since it doesn't, that one doesn't work. So it's just rotational symmetry. Rotational 72 degrees. Let's look at number 9. Okay, number 9. Alright, does this have rotational point or neither? Let's see. Well, rotational, you could rotate this down to the bottom here, and that would map up, and then rotate it back up to the top. So it does have rotational, and since it goes halfway around the circle, we can say that it has point, because the rotational symmetry is 360 divided by 2, or 180 for your angle of rotation. Since your angle of rotation is 180, it also has point symmetry. And that's number 9. Number 10. Does this bat have any place that we can fold it over onto itself? It does, but can we rotate it? And we cannot rotate that less than 360 degrees to make it match up. So your answer for number 10 is going to be neither. Number 11. Reflect line segment AB over the y-axis. What are the coordinates of A prime, B prime? Okay, so we're going over the y-axis. And you could do that just knowing what the numbers are, but let's do it visually first. If B is 3 spaces to the left of the y-axis, and we're going to rotate it over the y-axis, we just need to go the same distance to the right. 1, 2, 3, so B prime is right there. That's B prime. A prime is 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6 is going to go right there. That will be A prime. So the coordinates of A prime are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, 4. And that should be it. B is 3, negative 6. 1, 2, 3, down 1, 2, 3, 4, 5, 6. There you go. Checks out. Number 12. If C is reflected over the x-axis, what are the coordinates of C prime? So C is 2, positive 3. 1, 2. C is right here. Okay, if we reflect that over the x-axis, it's going to come straight down, same number. So the coordinates now are 2, negative 3. And that would be choice C. Number 13, if P has coordinates 2, negative 3, what are the coordinates of P prime? Under the translation, right 4 units and up 3 units. Okay, so P has coordinates of 2, 1, 2, and negative 3. 1, 2, 3. There's P now. That's P. I'm going to translate it right 4 and up 3. So right 4, we're going to go 1, 2, 3, 4. And up 3, 1, 2, 3, right there. And that will be P prime. Coordinates of that are 1, 2, 3, 4, 5, 6, and 0. So your choice is number 14. Rectangle PRST is vertically shown. What are the coordinates of P under the translation? X plus 9, y minus 4. Okay, that's P prime, so we're going to do X plus 9. We're starting here, we're going 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there. And then do y minus 4. 1, 2, 3, 4. The new point is right there. Those coordinates are 1, positive 2. Choice B. Number 15. Find the translation that moves the triangle to its new position on the coordinate plane. Okay, well first of all, the one with the prime is the new, and this is the old one, so we're going to have to move from this one to this one. So first we look at our x-coordinate. We're going from here, 1, 2, 3, 4, 5, 6, minus 7. And then minus 1, 2, 3, 4, 5. So x minus 7, y minus 5. Right there. If you want to see that on the picture, move it like this. X minus 7, and then y minus 5. That's number 15. 16. What is the image of point R after 240-degree clockwise rotation? The first thing we need to do is find out how many degrees each one of these angles is going to be. So we've got 1, 2, 3, 6 of them, and all the exterior are going to be 360. So we're going to do 360 divided by 6 equals 60. So every time we turn this one position, that's 60 degrees. And we're going to turn it from R, let's go circle that, 240 degrees clockwise. Clockwise is around this way, so 240. So let's find out how many clicks that's going to be. So we've got 240. Each click is going to be 60, so 240 divided by 60 is 4. So we're going 4 clockwise. So 1, 2, 3, 4. Yes. Or choice B. 17. What is the image of point N after a 120-degree counterclockwise rotation? Okay, so again, we've got 6 spaces, so angle of rotation equals 60 degrees. We want to move it 120. 120 divided by 60 equals 2. So we're going to have to move it 2 spaces. We're starting at point N, and we're going counterclockwise this time. So that's going to be going back this way. So 1, 2 right here. Choices are letter D. Number 18. A, B, C, D has been rotated 180 degrees around point E. Which point corresponds with point A? Okay. The easiest way to do this without patty paper is draw a line from B to E. Okay, we're going to rotate that 180 degrees, so it's going to go all the way down here. So that tells us that B is going to correspond with U. So if we rotate this all the way around, the one that's on the long flat side of A is going to be T. Your choice is C. Number 19. The dilation is a reduction. What is the scale factor? Okay, we were taught that scale factor is F equals the image over the pre-image, and the image is the new one, and the new one is going to have prime marks on it. So we have prime marks here, so we just need to set up our fraction. So let's find corresponding parts. 1, 2, 3, 4, 5, 6, 7, 8. It's going to be 8 over 1, 2, 3, 4 over 4. Okay. Okay, I think we did that backwards. Let's change that. Actually, it goes the other way. Let's go to pen. Our image is the new one over here, so that's 4 over 8. And if we reduce that, that gives us 1 over 2. Choice would be C. Very important to read the question carefully. 20. Sketch a 90-degree counterclockwise rotation of the arrow below about point R. About or around means the same thing. So we're going 90 degrees counterclockwise. So counterclockwise is going to be going around this way. We know the whole circle is 360, so if we just want to go 90, we're going to go down to here. Okay, and let's just sketch the figure. And that is 90 degrees counterclockwise around point R. And that is the end of your Unit 9 test review for transformations.